You're welcome to Muto Online, your YouTube channel for academic improvement. I'm teacher Mugulumiza Noah, a physics educator, and today we are going to look at some physics items in the new curriculum and the new lower secondary curriculum. The scenario of today is very interesting, and it's about electricity. So in this video, we are going to look at how we can possibly handle scenarios in setting electricity. Please subscribe, share, and like. Okay, we have a scenario here that tells us that parents are to visit your school on a science day, and among the things to be exhibited is house wiring. On the exhibition day, 3 excited parents approach you with 3 bulbs labeled 240 voltage, 30 watts. That was one parent. Another parent comes with a bulb that is rated 240 V, 20 watts. And then the other parent comes with a bulb that has 240, 25 watts, whose meaning is not known to them. One parent complains that he had such bulbs connected in his home, and when one blew, the rest went off, but there was no electricity. But there was electricity as seen from the main switch. And another one with the same type and the number of bulbs complained that he pays a bigger bill than the neighbor who also had 3 bulbs in the house. The electricity transmitted to your place is 130 voltage. As a physics learner, you're going to help parents to part A, understand the meaning of the labels on their bulbs, then knowing the wiring mistake that made the other bulbs go off, and also correct the mistake that was made in the wiring. Then we also have, with the explanation, having the problem of low energy supply to you, assist the parents on how all the bulbs can work efficiently, at the same time assuming they are all new. Then guide the parents on why one of them was paying a bigger bill, and advise them on how to avoid it if one unit costs 950 shillings. Then estimate the total bill, or what's their bill if the bulbs remain on the whole day. Now this scenario here, three parents came to you with the different bulbs labeled differently. One of the parents had a bulb rated 240 V, 30 watts. Another parent comes with 240 V, 20 watts. Then another parent comes with 240 V, then 250 watts. They didn't know the meaning of these things. As a physics learner, you need now to tell the parents what these bulbs or what are these ratings mean. What do they stand for? Such that you help them to get to know what they are seeing on their bulbs. Each bulb consumes differently. So each bulb consumes depending on how it is rated. These bulbs that the parents approached you with, they each consume differently. Now, to begin with the first parent who came with a bulb rated 240 V and then 30 watts. This statement or this rating means, that the bulb consumes 30 joules of electrical energy, per second when connected to 240 volt supply, like that. This statement, whenever you see a bulb or any electrical appliance rated, maybe it can be a heater, it can be mention them a blender or anything, as long as it is an electric appliance, it is each rated differently. Now, according to this parent's bulb, if it's rated 240 V, 30 watts, then this statement just simply means that the bulb consumes 30 joules of electrical energy per second when connected to 240 volt supply. This bulb, so power, we all know that power is measured in watts or joules. Now, that means that this bulb, when it is connected to a main supply of 240 voltage, it will only consume 30 joules of electrical energy per every second. Now, this second parent who approached you with this kind of a bulb rated 240 V, 20 watts, this statement or this rating simply means that this bulb here consumes 20 joules of energy, of electrical energy per second when connected to 240 volt supply. Then this one, it simply means that the bulb consumes 250 joules of electrical energy when connected to 240 volt supply main. So you see that. But as a physics learner, you should also be conscious. Look here. When you see 240, why is it that the main supply is 240? According to Ugandan law, the home consumption or the power consumption in homes, it is supposed to be 240. So when you check your television and everything that you use at home, the home consumption of power is supposed to be 240. Now, again in the scenario, they are telling us that the power in your area, it is all these bulbs, all of these parents, they are neighbors. But from your inspection, they told you that in your area, they have a main supply of 130 volts. But you look at their bulbs, they, like this one, consumes 250 joules of electrical energy when connected to 240. That's what it is supposed to consume. But in that area, the supply there, it is 130. That means there is less power. So these people, they are most likely to face a problem of power outages. And so we are going to help them and we see how we can rectify this. Another parent said that her bulbs are connected in series, but to her surprise, if one bulb goes off, or maybe if one bulb gets damaged, if one bulb blows, the rest of the bulbs totally don't work. She doesn't know what causes that. Now, as a physics learner, you should also widely open your mind and recall the two arrangements of connection arrangements. In electricity, we have two connection arrangements. That is parallel arrangement and then series arrangement. Series is when you connect positive to negative. Then with parallel, you connect positive to positive, then negative to negative. They each have merits and demerits. However, in this case, this parent has told us that the bulbs, the three bulbs were all connected in series. Okay, now let us find out where the problem came from. Just diagrammatically, I'm going to show you if a bulb is connected in series, then what are the most likely chances of power outages that this parent is supposed to or may eventually get? So, this is the problem in connection. Problem in connection. So if I'm to use some sketch here, if I'm to use some connection, we all know that this is a symbol of a bulb. So these are our bulbs. We can call it B1, bulb 1, bulb number 2, and bulb number 3. Then this is the supply, then this can be our switch. So that is our switch, and then current will have flow from this end to that side. But in your area, we have a main supply of 130 volts, like that. So when you look at this arrangement here, we have bulb 1, bulb 2, bulb 3. They are connected in series, positive to negative, like that. Now you see that if one bulb gets a challenge, this is current, this arrow is showing the flow of current. Now, supposing this bulb gets a challenge and it blows off like this, it automatically means that there is no current flowing through these two bulbs. Current flow has been cut off from this position. That means these two bulbs will also go off because the current flow has been interacted with, It has got a cut here. That means there is no flow of current. And so if there is no flow of current, these bulbs will not receive anything. And so they'll equally go off. So this is our bulb. So in our explanation, we can say that in series arrangement, if one bulb gets a problem, it affects the rest of the bulbs because it cuts off the flow of current flowing through the circuit. Now this is our circuit. Even when we complete it, and this bulb, either this one or this one, has a problem, it makes these other bulbs also go off because there will be no flow of current. However, we also need to give these parents now a solution. After them getting what could be their problem, then we have to find for a collection. Now this is a collection. Now, the parent told you that their bulbs were connected in series. Now you've told them where the problem is coming from. When one bulb goes off, the rest will also go off. So now this is how you can advise the parents to make new wiring of their houses such that the bulbs cannot go off. So instead of series arrangement, we shall now use the other way of arranging, that is parallel. So in parallel, here we shall have our circuit like this. Then we shall have our three bulbs. They are each connected in parallel like that. So this is my bulb 1, my bulb 2, and my bulb 3. This is current, this is switch, you can call it K. This is I. So we can have I1 here, and then we can have I number 2, current 2, shall have I number 3. Why do I have different currents here? This is the main voltage supply. From here, from the main supply, it is current. Now, as it goes on, it's going to divide itself into portions. So, current 1 will go here, current 2 go here, current 3 will go here. So this current I will now divide it itself into different currents such that each bulb gets. Now, look here. If this bulb gets a problem, maybe its wire gets cut. It stops giving light. But this does not affect these two bulbs. These two bulbs continue giving light. Why? These two bulbs are getting connection or are getting two wires. One is here, another one is here. So this bulb failing to give light does not affect these two bulbs. In other words, if one bulb fails here, the rest of the bulbs will continue giving light, unlike the series arrangement. So you see that parallel arrangement is better in connection than the series arrangement, because we've seen that in series arrangement, if we have a damage here, these two will be affected. But in parallel, if I have a challenge here, this bulb will stop giving light, but the rest will continue giving light. So in collection here, you can say, I advise the parent to use parallel arrangement. Then you explain furthermore. In parallel arrangement, if one bulb is faulty, it will not affect the rest of the bulbs as it will allow the flow of current to continue, as you've seen here. And you can even illustratively show them what you basically talking about. Now, after having seen that, one parent also said, because now we are handling the parents' concerns, that with explanation, having the problem of low energy supplied to you, assist the parents on how all the bulbs can work efficiently at the same time, assuming they are all new. Okay. Now, in your area, the power supply is 130 V. But these parents, they have bulbs, each rated 240 V, 240 V, 240 V. That means these bulbs, they each consume power when connected to a main supply of 240 volt supply. But in your area, you only have 130 volt supply. That means we have to look for ways on how we can step up this power such that it can match the standard of the bulb's ratings. Now, we already have 130. This 130 is less than 240. That means we need a transformer that will step up this voltage from 130 to 240. But remember, in transformers, we have two types of transformers. We have a step down transformer and a step up transformer. In this case here, since we have a voltage less than the required, then we probably, or we honestly need a step up transformer such that we can we can step up our power from 130 V to 240. So we can still diagrammatically showcase this. This is our part B. We can say we already know, we've agreed that the parent is going to be using this parallel arrangement. So this is our parallel arrangement. These are the bulbs. These are the bulbs. So these bulbs here, we are going to connect an alternating current here. This is, shall connect a step up transformer around here, step up transformer, but we need a protective resistor that can break the circuit in case of too much power. So we shall have a protective resistor around here. Then this is the 130 V that we want. Now the output voltage will be this side, output, and that will be 240, such that it matches with the bulb's ratings. So this is output voltage, output voltage. So My bulbs are here. My bulbs are here. Like that. So in your explanation, you say, connect a step. This is step up transformer. Connect a step up transformer across a protective resistor to a 130 volt supply main. Now, the essence of this transformer is to amplify the voltage from 130 to 240 volts such that it matches with the bulb's ratings, because these parents, they each have bulbs rated 240 as the main supply connection. So when we connect a step-up transformer with a protective resistor to break in case of the too much current flowing through it, then 130 V will be amplified to give the 240 volts, which will match the ratings of the bulb. Now, the last part, we have also another complaint from the parents that get the parents on why one of them was paying a bigger bill and advise them on how to avoid it. If one unit costs 950, then what is their bill if the bulbs remain on the whole day? So these people, one of the parents was paying bigger much as they had the same number of bulbs. The connection was not the same, and even maybe the time of switching on the bulbs was too different. So what we are going to do to help these parents, part B, this is now part C. We are going to give the possible ways on how we can help this parent. One parent was paying a bigger bill, so we have to give reasons why the other parent was paying a bigger bill. So one parent was paying a bigger bill. One parent was paying bigger bill due to, now we can highlight some reasons why. One, due to switching on bulbs for a long time, for a long period of time. So the more these bulbs take long when they're giving light, the more electrical energy will be consumed, and so they will still pay much amount. Then also, the bulbs that they were using, one bulb was 30, another one was 20, another one was 240. All that energy consumption is too big. These parents, they can use other ways like energy savers. So another reason why one parent was paying bigger, it is because the bulbs that they were using, or they had, parents had high energy consuming bulbs, had high energy consuming bulbs. So these parents, they had bulbs that were consuming electrical energy highly. So, however, still you can give them the solution on how they can reduce on the electricity bill. One, reduce on the hours. If you've been switching all these bulbs for 10 hours, let them switch on at least for 8. By reducing the number of hours, even the bill will reduce. Then, had high energy consuming bulbs. Let them use bulbs that consume less electrical energy, probably energy savers. Then, the other last part, it is requiring us to find the total amount of money paid as electricity bill. So in this, we shall say we shall say cost of electricity is equal to units multiplied by cost per unit. So to get the cost of electricity, we shall say units times cost per unit. But units themselves, it is power in kilowatts times hours. Then after times the cost. So this is the same as power, but this power in kilowatts, then times hours. Then finally, this stuff times the shilling, which is 950, the cost of each unit. So power, we have each bulb. The first bulb was rated 340, was rated 240 30 watts. So the power consumed by that bulb was 30 watts. Then plus another bulb that consumed 20 watts. Then plus another bulb that consumed 250. But we want power in kilowatts. So all this will be divided by 1,000, like this. Or even you can split them, or you can simply leave them. Now we can just do it overall here times hours, but they want us to calculate the bill if all these are switched for 1 day. Now you ask yourself, a day has how many hours? So in this, we shall assume that a day has 24 hours. And if a day has 24 hours and these bulbs are switched on for the whole day, that means they'll be switched on for 24 hours. So we shall say times 24 here, then times 950. This will give us the cost of electricity consumed. So when you have all that, you see that you have around 1,750 shillings as your answer. So this is the money they have to pay after 24 hours if they continue maintaining those bulbs. Subscribe for more Muto Online, like and share.